We have a problem statement here. Let me read it for you. A positive integer is entered through the keyboard. Write a function to find the binary equivalent of this number without using recursion and using recursion. So we need to write a iterative logic to convert the decimal number to its equivalent binary number. And we also need to write a recursive logic. So we will be writing two functions, okay, in this program. So let's learn basics about decimal and binary number systems. In decimal number system, the base is 10 and it uses 10 digits ranging from 0 to 9 to represent all the numbers. 10 digits are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Whereas binary number system has a base of 2 and uses only 2 digits, that is 0 and 1, to represent all the numbers. So let's bring up binary number system chart. So 2 raised to 0 is 1, 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8 and so on. So this is binary number system chart. If user enters a decimal number, maybe 14, so decimal number system has a base of 10, okay, we convert it to its equivalent binary number, that is 111 and 0. I'll let you know how to convert that. But once we convert it, we can even verify it by writing 1 into 8 plus 1 into 4 plus 1 into 2 plus 1 into 0. If you multiply and add it, you will get the original number, which is in decimal form, which is 14. Okay, so this is how we verify if our binary number is actually equivalent to its decimal counterpart. So how do we arrive at this binary number 111 and 0? It's easy. I'll show you the logic here. So modulo divide the number by 2 itself, because binary number system has a base of 2. So get the remainder. In this case, 14 modulo division 2 is 0. The remainder is 0. Next, divide that 14 by 2. You will get 7. Again, modulo divide the number 7 by 2. You will get the remainder of 1. Again, divide the number 7. You will get 3. Modulo divide 3 by 2. You will get a remainder of 1. Divide 3 by 2. You will get 1. So now write these numbers from down to up, that is 1, 1, 1 and 0, which is equal to our number present here. Okay, so we have explained this logic completely, that is iterative logic, in a separate video tutorial. Please go watch that before continuing with this video tutorial, link to which is present on your computer screen right now. It's a small video, so please go visit the URL and learn it before continuing it. So let's get started to write our logic using our C editor. Code blocks. Okay, I'll take an integer variable num and I'll ask the user to enter a decimal number and store it inside the address of integer variable num. So let me write printf statements directly. So binary equivalent of %d is %d. So the original number is present inside num and the result will be returned by our function binary, to which we will pass the user entered decimal number. So let me write a printf above that to let the user know that it is an iterative logic. So let me insert a couple of new line characters at the beginning and one more new line character at the end. So let me copy these 2 lines of code and change this to recursive logic. Recursive logic, it's right. Let me change the function name to binary_rec. First, these 2 lines of code executes and displays the result. After that, this n. Okay, so first 2 lines gets executed first and its results will be displayed. After that, these 2 lines gets executed and its results will be printed. So first let me define this iterative logic inside binary function. So it has to return integer type value, so its return type will be int. It also takes an argument of type integer. I'll call the variable name as num itself. So let me write the iterative logic now. So let me write while loop first. So let me reduce the number by writing num is equal to num division 2. Okay, to terminate this while loop. So what will be the condition inside this while loop for this while loop? So while num is not equal to 0, keep iterating. Once num is 0, exit the control from this while loop. So take this first condition, 14 modulo division 2 will give us a reminder of 0. So we need to calculate reminder. So num modulo division 2 gives reminder. Also, let me calculate its decimal place. So unit 10, 100, 1000, 10,000. So it increments by 1 0. So let me multiply the initial value of place, which will be 1, by 10. So I'll initialize the value of place to 1. Now let me calculate the binary equivalent. So bin is equal to previous value of bin plus the value present inside reminder into its place. So placing the reminder in its proper decimal place. Okay, so let me return the value of bin, which has binary equivalent of the user input decimal number. So let me define the variable bin and assign it a value, initial value of 0. Okay, so let me comment these 2 lines of code and first check if this logic is actually working. So let me give 45 as decimal number. So let me check the output, 101101. So the final result is 45, which is the decimal number entered by the user. So this logic is working properly. So let me remove these comments and now define the recursive logic to find binary equivalent of the user passed decimal number. So it should return integer value, so its return type is integer as well, and it takes an integer number as argument. So I'll take a local variable to copy it, int num. So we need to replicate this iterative logic into recursive logic. So this will be our base case. This while loop iterates until num is not equal to 0. So let me use that logic. We will write the opposite of that here. If num is equal to 0, return 0. So this is how we terminate the recursive nature of this function, by returning the value 0 when num is equal to 0. Else, so let me return. So this is the important part of calling recursive function. So let's use this logic. What shall we do? Let's reduce the number first by writing num division 2. So let me recursively call this method or function binary underscore rec, and instead of num I'll pass num division 2. Let me reduce the number. Okay, so at some point num will be 0 and it will return 0 and the recursive nature will be terminated. So this, let me do this. So let me add the reminder to this and also the placement thing, that is multiply this result by 10. Let me put brackets here to make it look clear. So don't get confused here. You are multiplying it with the reminder, that is the place 10. Don't confuse it here. Binary of rec will fetch us the binary of that passed number, and we are placing it in its proper decimal place by multiplying that return number by 10 and then adding the reminder, that is num modulo division 2, to the result. Okay, so you will know the logic shortly. So let me save and compile and run this program, and let's first check if it's working properly. I'll give 45 itself, and both the result are same. So let me give 14 now. So using this binary chart, go ahead and calculate, verify if 1110 is actually equivalent to the decimal counterpart 14. So let me explain this recursive logic once again. I'll copy the entire function and paste it here. Let me bring this down. Hope you're able to see this clearly. Please make this YouTube video a full screen so that you can view it properly. So if user enters decimal number 14, inside main method itself, it calls the function binary underscore rec and passes the user entered number, that is 14, to it. So 14 is not equal to 0, so this gets executed, this line of code. So substitute the value of num by its value, that is 14. 14 modulo division 2 is 0 because 14 is perfectly divisible by 2. 14 divided by 2 is 7. So this is recursive call, that is binary underscore rec of 7, wherein 7 is the new number, new value of num. So num is not equal to 0 once again, so this line of code gets executed. Let me paste it here. Substitute the value of num by 7. Now 7 modulo division 2 is 1. You can check that out. So 7 division 2 is 3. So again recursive call. This time the new value of num is 3. Again num is not equal to 0, that is 3 is not equal to 0. So again this line of code gets executed. Let me replace the value of num by 3. So 3 modulo division 2 is 1 once again. So 3 division 2 is 1. Again a recursive call, binary underscore rec with the new value of num as 1. So 1 is not equal to 0, that is num is not equal to 0. Again this line of code gets executed. Replace the value of num by 1. So 1 modulo division 2 is 1. 1 by 2 is 0. So again recursive call, this time the new value of num is 0. So num is 0 here. So again recursively call this function. So num is 0. So this line of code is executed. Okay. So 0 will be returned to the calling function which is present here. So replace it. So 10 into 0 is 0, plus 1 is 1. So this will be returned to this calling function. So 10 into 1 is 10, 10 plus 1 is 11. So this will be returned to the calling function. So 10 into 11 is 110, 110 plus 1 which is 111. Okay, this result will be returned to this calling function which is 1110. Okay, so this will be passed returned to the main method where binary underscore rec of 14 is called. So binary equivalent of 14 is 1110. This will be displayed onto the console window. So again check this, 1110. You can verify it using by bringing up the binary chart. Okay, you can write this logic using ternary operator too. Let me show that to you as well. By now you already know how to do that, but if you are new to our channel, I'll show it to you. So I'll write the condition num if num is equal to 0. Okay, in that condition return 0, else return this line of code. That's it. So one line of code will do the job. So let me bring this down if you are not able to see it properly, and remove these things. This should work fine as well. So let me compile this, save, compile and run this program. So enter a decimal number 14. So its binary equivalent is 1110. So let me write the prototype and finish this program. Copy and paste this. Let me remove the variable names. It's optional, by the way. So let me cut the function definition out of here and paste it below main method. Okay, let me run the program once again. I'll give 14 once again. Again it's giving the right results. Let me run this program once again and give 45, decimal number 45. So 101101 is binary equivalent of decimal number 45. You can verify it. Okay, so for verification, the binary number system chart and everything, that is source code, discussion and notes, for everything please visit the link present in the description section of this YouTube video. As I said you, to get the source code, notes and discussion about this topic, please stay subscribed to our YouTube channel and blog. Share this video with your friends using your WhatsApp, Telegram, WeChat, or maybe LinkedIn, Twitter, Facebook, etc. And please do not forget to like this video on YouTube. Thank you.